So, looking at your layers of the atmosphere, we are going to start at the bottom. We're going to start at that bottom layer, the closest to the surface of the Earth. And this layer is called the troposphere. So this is what we're focusing all of the notes on at this point. I'm going to zoom in now for you. And go ahead and add the label troposphere to this layer, kind of up in the corner like I did there. Now the troposphere is from 0 miles, so starting at the surface of the Earth, up to about 6 miles up. Okay, so this first 6 miles closest to the Earth is called the troposphere. Now the troposphere is going to include mountains. Even our tallest mountains are nowhere near to the top of the troposphere. And so as you're doing your notes now, you are going to add both illustrations and words to your notes. I'd also like you using color as you go along. So make sure as you're adding these in, you're using the colored pencils to enhance your drawings. The troposphere ends at a point called the tropopause. So that place where this layer ends is called the tropopause. And that's because we'll have a temperature change. We'll look at that in more detail in a minute. The troposphere is where all cities and towns are, and that's what those little columns there are representing, like buildings in a city. 75% of all of the air in the whole atmosphere is found at this point here in the troposphere. Now, think of air as kind of like a big pile of molecules, all right? And there's more on the bottom because of all of the air above it that's pressing down. Even air, even if it's invisible, it is still affected by gravity. It's gravity that is holding our atmosphere on, actually. This is where all weather occurs. The weather completely occurs in the troposphere. This is where airplanes fly. Okay, so take a minute, pause if you need to make sure you have all this stuff in here. Add your labels and explanations. This is where we exist. This is where we live. We entirely exist in the troposphere, unless you're an astronaut. All right. So we ask the question then, as you travel through this layer, starting at the bottom and moving up to the top, let's talk about what happens to the temperature, to the density, and the pressure. Okay? Well, first of all, the temperature, as you travel up in the troposphere, the temperature decreases. And this happens because we have all of this solar energy hitting the surface of the Earth, and it warms up the surface of the Earth. And that basically reflects a lot of that energy back up and heats things up. As you get further away from that reflected heat, the temperature decreases. On the other hand, the density of the air as you go up also decreases, as does the pressure. Okay? So the density of the air, remember that density is how close the molecules are together, how tightly packed. So let's take a look at this for a second. Imagine that we have this column of air, if we just wanted to look at one column of air. And we would have, excuse me, all of the air above pressing down on the air below. Well, the result is going to be we are going to have our most dense air closest to the Earth. And as we go up higher and higher through all of these, it will become less and less dense. Pressure is just simply the weight of the air pressing down on whatever is below it. And so again, when the density goes down, the pressure will also go down. So next we're going to take a look at the next layer, and this is called the stratosphere. So we're going to zoom in here on the stratosphere, and you can start drawing these little structures here in this layer. These are the letter O, and they are representing atoms of oxygen. Now when you put 3 of those together, that's called ozone. Okay, now the stratosphere goes from 6 miles up to about 31 miles. And the top of the stratosphere is called, you got it, the stratopause. All right, so in here, in this layer is where we have 24% of all air. So remember previously we had 75% of the air, right? Now 24%. most of our air is in these first two layers, right? Now, also what's important here is the ozone layer. So that's what these little guys are representing here. They are representing molecules of ozone, and the molecule for ozone is O3. So it's 3 oxygens connected together. Now, the oxygen that we breathe is O2, 2 oxygens bound together, okay? So the ozone layer is unique in that it is able to protect us from UV radiation, okay? So I want you to make sure that you do something in your drawing to show UV radiation coming in from the sun, whatever way makes sense to you. You'll notice a little bit will get through, and that little bit that gets through is the reason that we still need to wear sunscreen and protect ourselves from the sun, okay? But most of it, in fact, gets absorbed and reflected by the ozone layer. Okay, so this is really important in regards to protecting us from all of that radiation from the sun. So in this case, if we start thinking about what happens as you travel up through this layer, is that the temperature, in fact, starts to go up here in this point as you travel up. Now, the reason the temperature goes up through this layer is because this layer is absorbing a bunch of solar radiation. And that solar radiation is heating things up and it's getting trapped there. Now, the density will continue to go down and the pressure will also continue to go down. Now, please make sure you check and make sure you've got everything you need before moving on. Our next layer is called the mesosphere. The mesosphere. Now, meso means middle. I'll go ahead and label the mesosphere. And this goes from about 31 miles up to about 53 miles. And the top of this, as you might have already figured out, is called the mesopause. Now, the mesopause is where it stops before it becomes our last major layer. Now, less than 1% of all air is here. And this is the place where meteors usually burn up. So make sure you write that fact in. And then I want you to maybe show some meteors coming in here. If a meteor doesn't burn up, you might end up with something like this in a big crater. As you can see, this one that was found in Mexico, and they've built an amphitheater around it. Meteors are made of really heavy metals. They're flying through space. When they burn up in the mesosphere, we see those as shooting stars. So on this layer, I want you to make sure you draw some meteors and have these facts written. And as we travel through this layer, let's talk about what happens to each of our 3 measurements here. Okay, so the temperature as you travel up here now starts to go down again. That's where our change in temperature happens. The density continues to go down and the pressure continues to go down. So now this brings us to our last layer, which is really one big layer that has like 2 subparts to it. This whole layer is called the thermosphere. But when we zoom in a little closer, we'll name these separately, the ionosphere and the exosphere. So go ahead and add those labels in, and this is 53 miles to about 310, which is a little debated about where the atmosphere actually ends. Less than 1% of the air is here, and in the ionosphere, starting there, this is where you find northern lights. Okay, so you are going to draw an amazing picture of some northern lights here. All right, I don't know if anybody has ever seen those, but they are incredible. If you haven't, you have to make sure that you do sometime. And you're going to find out a little bit more about northern lights a little later on in this unit. So for right now, I'd like you to pause and draw a nice little picture that's going to represent the northern lights. And make sure you add that fact there that northern lights happen in this layer. And then finally, our last layer is the exosphere. And exo means out or going out, right? It's the outermost layer. And this is where we have the satellites and other like astronomical things here, out here in this area. This is where things are orbiting the Earth, are happening here in this layer. And so label this, please, with that fact about satellites and other astronomy instruments. Maybe draw a few satellites up there showing what's going on in this area. And now as we look at what happens as you travel up through this layer again, this is a point where the temperature actually starts to go up again. And that is because we are getting so far out, there's nothing between this layer and the sun. And so the sun's direct solar radiation is in there and heating things up. The density continues to decrease until there is actually no molecules of air left, and the pressure also decreases. Take a second to check this before you go on. Make sure you've got everything. So now if we go ahead and add our arrows here in the end, you can see like a pattern here on your overall diagram. Again, if we go back to thinking about that column of air, with the density and the pressure, you can see that this just continually decreases as you go up. And if you look at this diagram, that kind of helps illustrate that. The temperature, on the other hand, has these changes that happen. All right, so when you're looking at the temperature, you can see that it is not consistent going from the surface of the Earth up to the outer part of the atmosphere. And so I'd like you to please use some colored pencils right now. Use blue and red specifically, like I have on here. And please color these boxes in, with red being used to show when things are heating up, and blue showing when things are cooling down. The last thing you need to do here is I'd like you now to quick check page 13. Now that you have these notes, when you turn to page 13, I'd like you to check your answers on the chart at the bottom of the page. You had to make some inferences to answer that chart, and at this point you might find that some of your answers are not correct. So check them to see if you have anything that you need to change. And this is the end of part 1.